The structure of Mars Orbiter mission is a cuboid of size 1.48 by 1.48 by 1.58 meter cube, and the structural components are of honeycomb sandwich construction. The structure consists of primary, secondary and tertiary structure. The primary structure is a load-carrying member, and it consists of bottom deck with interface ring, thrust cylinder and 5 numbers of shear webs of CFRP face sheet and aluminium honeycomb core structure. This completes the primary structure assembly. After the arrival of primary structure assembly in clean room, the first activity is the integration of propulsion elements. The propulsion system configuration in Mars Orbiter mission is bipropellant chemical propulsion system. It consists of 2 numbers of propellant tank of capacity 390 liters, one for fuel, which is monomethyl hydrazine, and another for oxidizer, which is nitrogen tetroxide. A pressurant tank of capacity 67 liters is used in pressure regulated mode. A 440 Newton liquid engine is used for earthborne maneuvers and during Mars orbit insertion phase. 8 numbers of 22 Newton thrusters are used during spacecraft attitude maneuvers. The flow of propellant is controlled through various valves, namely check valves, isolation latch valves, fill and drain valve, etc. In addition to this, pressure regulators and filters are used for optimum performance of the system. This propulsion system derives heritage from Chandrayaan-1 spacecraft. The secondary structure consists of top deck and 4 vertical panels, namely the negative yaw panel, the positive yaw panel, the positive pitch panel and negative pitch panel. 2 star sensors are configured in Mars Orbiter mission, namely the Mark II star sensor and Sodan star sensor. One of the low gain antenna is mounted outside the panel for communication during earthborne maneuvers. The entire S-band communication packages like the transmitter, receiver, 250 watt travelling wave tube amplifiers, diplexers, circulators, switches etc. are accommodated inside this panel. 9 numbers of coarse analog sun sensors are accommodated in different orientations on various panels to take care of attitude during safe mode detection and initiation. The attitude and orbit control electronics and the telemetry and telecommand packages of both main and redundant chain are mounted inside the positive yaw panel. The second low gain antenna and MENCA, that is the Martian Exospheric Composition Explorer payload, along with the power converters, are mounted outside this panel. This MENCA payload requires orientation along the velocity vector direction of the spacecraft. Three payloads from SAC, namely MSM payload, that is methane sensor for Mars, MCC, that is Mars color camera, and TIS, that is the thermal infrared imaging spectrometer, and their related logic units are accommodated on negative pitch panel. These payloads need to look towards Mars surface, that is the positive yaw axis of the spacecraft. The payload power supply units, lithium-ion battery of 36 ampere-hour capacity, and the data handling package are mounted inside this panel. The power systems like the core power, distribution electronics, EED package and wheel drive electronics are accommodated inside the positive pitch panel. The solar array, which consists of 3 numbers of solar panels of size 1.4 meter by 1.8 meter with yoke and solar panel drive mechanism, are accommodated outside this panel. 4 numbers of reaction wheels of capacity 5 nms are mounted on top deck in tetrahedral configuration. Lyman alpha photometer, that is the lab payload, is mounted outside this panel looking towards Mars surface. The sensor processing electronic package is mounted inside this panel. After the completion of functional tests of all these packages, the next activity is the closure of panels on primary structure. The panels are closed sequentially and the dummy top deck is replaced with a flight top deck. For accommodating high gain antenna hold down points, the negative pitch panel size is extended by 750 mm beyond the top deck. In order to support the extended size of negative pitch panel, a box type structure is configured. The high gain antenna feed and the medium gain antenna and 2 numbers of CAS are accommodated in the box type structure. After the closure of all the panels, the appendages of solar array with yoke and high gain antenna reflector are mounted outside the positive pitch panel and the negative pitch panel respectively. After the measurement of physical properties of the spacecraft, the 440 Newton liquid engine is centrally mounted below the bottom deck. The high gain reflector of diameter 2.2 meter is stowed during launch configuration using 2 hold down and release points and will be deployed immediately after separation from launch vehicle. The outermost cell side of the solar array is exposed to sun in stout condition. The deployment of solar panel is in 2 stages, that is, the primary and the secondary. The primary deployment takes place 22 seconds from snap. After confirmation through telemetry of micro switch for primary deployment, initiation of secondary deployment will be issued manually after ensuring positive hinge temperature. This shows the on-orbit configuration of Mars Orbiter mission. This shows the stout configuration of Mars Orbiter mission. The lift-off mass of the spacecraft is 1340 kg and the propellant mass is 852 kg. The spacecraft interface ring is assembled onto the launch vehicle through payload adapter using 937 VB clamp band separation system. The usable volume of PSLV envelope is 2.9 meter diameter. The heat shield is closed after the successful integration of spacecraft onto the launch vehicle.